Okay, hello everyone. This video, I'm going to show you another example to calculate the shear force in the boat. Okay. And the previous video we introduced in, I think it's called double shear. Okay, and this is we have more shear. Okay, more shear. Okay, and in this example, I will also want to learn how to draw the free body diagram to analyze the shear force in the boat. Okay, and you see this problem, it has the same problem description as the previous one. Okay, determine the largest internal shear force resisted by the boat. Okay, and then include all necessary free body diagram. Okay, for this boat problem, I think it's better to analyze from the middle part. Okay, from the middle member. Okay, looks like it's very much easier to analyze. Start to analyze the middle member. So for this problem, so actual the middle member, I think is here. Is this two? Okay, and this two, I think I give it the name. Okay, this is A, B, C here. So I call this D, then I call this E. Okay, we start to do the analyze start from D and E. Okay, looks like it's much easier. Okay, if you start from A, B, C, I think you have to start to make some assumption. Okay, so it's not that easy. Okay, let's start from the D first. Okay, let's start from D. There's an external force 10 kilonewton pulled on D. Okay, so and the D has a shear plane. It has a shear plane with A and B. So this is a shear plane here. D contact with A. Also D contact with B. Okay, and the bolt is here. Okay, here is the bolt. Bolt is here. I maybe draw. Yeah, because it's transparent. It's not really not that visible. Okay, so there's the bolt is here. Okay, here is the two shear plane. D contact with A, D contact with B. So when I apply force on D, okay, the D will subject to the friction from the A and from the B. Okay, so let's draw a free body diagram on D. Okay, this is D. Okay, here is a 10 kilonewton to the right. Okay, and pull the D to the right, so the D will subject to the friction from A and B. So there was some friction here. Okay, and this friction it's also the shear force. Okay, because this force is lie on this plane, so it's shear force. This friction is just the shear force, and this force we have to be careful. This force is done by A, so this is A to D, A to D, and here is B to D, B to this shear force is B to D. B exerts shear force on D. And the free body diagram, very important thing is we have to draw the force acting on the same body. Okay, so this force, and this force acting on the same body. And because the D everything is static, so these two forces must be equal, okay, and opposite to the external force. So this force will be 5 kilonewton and 5 kilonewton. Okay, so this is the free body diagram of the D. Okay, and the next thing is the next thing is A and B. A and B. Okay, and A is up. So A, let's draw A here. Okay, A is here. Okay, let's start from the A. Okay, A is here. Okay, okay, so the A has the force. Okay, oh sorry, so A there's an external force on A. Okay, 6 kilonewton to the right. Okay, so the A has a force on D. A has force on D. So actually there's an action reaction force. Okay, This is action A to D, so there must be a force equaling opposite. Okay, equaling opposite. Okay, and it's D to A. Okay, action and reaction force. Action and reaction force. They're acting on different objects on different body. Okay, a force is this force A to D, so there must be a reaction force. I mean, it's D to A. Okay, and it's equal opposite, so it's also 5 kilonewton. Okay, and in this project, in this topic, everything is static. So here so there must be another force acting on A to make the A is static. So okay, because right now A we have force 6 kilonewton point to the right, and this is a force 5 kilonewton point to the right. Okay, so there must be a 11 kilonewton point to the left to make everything statics. Okay, okay. Here's the free body diagram on the A, and also the next thing is what's the free body diagram of B? Okay, let's draw this B. But I since I don't have any space here, so I mm, okay, where should I? Okay, just maybe I just draw here. Okay, maybe it's not in right position, but okay, this is a B. Okay, B, there is an external force on the B, but its external force point to the left. Okay, so from the D, we know B has a exert a force on D. It's the same action reaction pair. There must be a force D to D to from D to B. So here is D to B. Okay, it's equal and equal and opposite. So it's 5 kilonewton. Okay. And B, okay, let me see. Okay, B, is that all? Okay, that's not the whole story. Okay, because yeah, for B there's another B also contact with E. Okay, B also contact with E because here. B also contact with E. Okay, this is shear plane. Okay, and this also another shear plane. Because B contact with E, so we have to consider some shear force, the force if the force of that is exerted from E to B. Okay, so maybe right now it's not the right time to draw the free body diagram of B. Okay, okay, so okay, I think right now we have to draw the free body diagram on E first. Okay, okay. Okay, we have to start from the E first. Okay, so if you, yeah, because B contact with E, so we have to solve the E first, and then we can go back to the D. Okay, so because E is easier to handle. Okay, so where should I put E? Okay, that's from, okay, maybe, okay, move to here. Hmm. Move to here. Mhm. Okay. Okay, let's start from this E first. Let's start from E. Okay, let's start from E. Okay, E is the external force exert on E. Okay, so and E's contact with B and C. So if I push the external force acting on E, so the E is subject to friction from B and C. Okay, the E is subject to the friction force from B and C. Okay, and the friction force, I think the friction force will make the whole body static. Okay, so the friction force from B and friction force from C must be opposite to this force. So this must be here. Okay, this is okay. This friction force is B to E. Okay, and this friction force is C to E, and it must be equal. Okay, and they must be to the same to each other, and this must be 4 kilonewton, this must be 4 kilonewton, and to balance the whole object, Okay, so make everything static. Okay, we solve the E out. Okay, and next we can use this information. We can use and draw the free body diagram on the B and C. Okay, let's start from B first. Okay, B. Okay, this is not right color. Okay, B is here. Okay, so B, when we see the B, there's external force here. Okay, and let's us see B contact with D, B contact with D, B contact with D. Okay, so in previously we know B has a force acting on D, so there also must be a reaction force, and that reaction force is from D to B. Okay, equal and opposite. D to B is 5 kilonewton. Okay, and in the free body diagram of E, we know there's a force exerted from B to E, so there must be a reaction force, equal and opposite, point to this direction. It's E to B, and it's 4 kilonewton. Okay, and then let us check, is this balance? Okay, 4 point or 5 point to the right, and this 4 is a 8 point to the left. So overall is point to the overall is point to the left. Okay, but like I said, in this course, everything is static, so there must be a force. There must be a force here, and it's 3 kilonewton. There must be a 3 kilonewton here to make everything balanced and static. Okay. Okay, so that's the free body diagram of the B. Okay, so the final one, this is the B, this is the E, and final one, there is the C. Okay, for C, okay, finally we reach the C. C is here, and there's a 20 kilonewton external force acting on C. Okay, and C only contact with E. Okay, so and that's good. We only contact with E. So in this free body diagram of E, we know there is a force from C to E. So at the same time, there must be a equal and opposite reaction force, and it's from from E to C, E to C, and equal and opposite. So it's also 4 kilonewton. So okay, so overall here is this balance. Looks like it's not balanced, but everything is statics. So there must be a force here, and it's 16 kilonewton. Okay, and then make the whole system, not whole system, make the C, the member C, static. Okay, so we have to write all the free body diagram out. Yeah, it's very long process. A, B, C, D, 5 free body diagram. Okay, but I hope you can understand and familiar with process. Okay, because yeah, draw a free body diagram is the basic for rich body equilibrium. Okay, but previously we don't have much example on this, right? Yeah, but you will see lots of free body diagram in this course. Okay. Okay, so the problem is determine the largest internal shear force. Let us see what shear force do we have. Okay, this is shear force. Okay, this is shear force. Shear force. Yeah, this is a shear force. Shear force. Shear force. Shear force. Shear force. Okay, let's look at what is largest shear force. Yeah, it looks like it's 5 kilonewton, right? 5 kilonewton is the largest value of this shear force. This is 4, 4, 4, 4, and it's 5, 5, 5. So the largest value is shear force of 5 kilonewton. Okay, so the largest shear force in this boat, this boat is 5 kilonewton. Okay, okay, so this is a very complicated process, but I hope you can familiar with this process. Okay, everything is static. Okay, in this course. Okay, so an action reaction pair. Don't forget that that's very basic Newton's law, right? But I think you haven't used this a lot. Yeah. Okay. So I just start a video here and see you in next example. Okay, so okay, yeah, get familiar with this. Okay, so I just start video here. See you next video. Bye bye.